Hi, welcome to this lesson on Analytical Geometry, Tangents to Circles, Part 1. Let's have a look at question 1. A circle with center C, 8, negative 7, and the points P, 5, negative 5 on the circle are given. Determine the gradients of the radius. Okay, so 8, negative 7, that will be somewhere over here. And the points 5, negative 5 would be somewhere over here. P, 5, negative 5. Okay, so essentially the circle would look something like this, roughly. Okay, so now you want to find the gradient of the radius. Okay, so the radius here that we're referring to is the radius line CP, because that's the only radius we can actually work out. Okay, so again, I'll have to use rise over run here. From 8 to 5, sorry, that is not where that point should be, right? 5 is not greater than 8, so it should be on the left. Okay, so it should be over here somewhere, P, 5 and negative 5. Okay, that's better. There we go. Okay, so again, from 5 to 8, you've moved across 3 units, and from negative 5 to negative 7, you move down 2 units. Okay, so the gradients of the radius line are, because it's decreasing, going from left to right, it's going to be negative, and it's rise over run, so negative 2 over 3. That is the gradient of your radius line. Then you want to determine the equation of the tangent to the circle at P. So again, let's draw in that point there, C, 8, negative 7. Okay, and then the circle looks something like this. And you had a point P here, which was 5, negative 5. Okay, and we had the gradients here, the gradients there. Okay, so now we want the equation of the tangent line at P. So the tangent line is that line over here in green. Okay, and notice it's perpendicular to the radius. Tangent is perpendicular to the radius. So to find the equation of this line, y equals mx plus c, the tangent line, we first of all note that the gradients of the tangent times the gradients of the radius must be negative 1. That is because your radius is always perpendicular to your tangent in a circle. Okay, so therefore we have the gradients of the tangent times, we worked out the gradients of the radius was negative 2 over 3 equals negative 1. So therefore, if I get rid of this negative 2 over 3 by multiplying by negative 3 over 2, I get my gradient of my tangent is going to be positive 3 over 2. And that makes sense. The line is increasing from left to right. So I've got y equals 3 over 2x plus c. And then I can substitute that point P, 5, negative 5. And I get negative 5 equals 3 over 2 times 5 plus c. Okay, so I'm going to get negative 5 equals 15 over 2 plus c. And then if I subtract 15 over 2 on both sides, I have negative 5 minus 15 over 2. Okay, negative 5 I can write as negative 10 over 2, so it has the same denominator, minus 15 over 2, so I get negative 25 over 2. So, therefore, the equation of this tangent line is given by y equals 3 over 2x minus 25 over 2. Okay, and that is the equation of the tangent line at that point P. The key thing here is noting that the tangent line and the radius are always perpendicular, so therefore you can always work out the gradient of the tangent line and then substitute the point of contact to get the equation of that tangent line. All right, awesome. I'll see you guys in the next one.